This is the first example where I've got a K-map with 4 different terms. So my table is going to get bigger again. Again, you need to know the order of the headings. So you start with the same at the top, but of course this time I'm going to have CD, CD, CD and CD. And I need to know how to label my knots. And the same order applies as did so to my top heading earlier. So I go knot, 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 and knot. And that's the same here. I'm going to have knot, 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 and knot. So this is an order to remember. So when I want to start mapping these terms, I use the same method as before. In this case, I've got AB and I've got CD, which is here. I've got not A and B, which is here, and then CD, which is here. A and B, which is here, and not C and D, which is there. And the final term here fits into not A, B, not C, D, there, and all of my other terms are equal to 0. And when we want to find our groupings here, then you can see in this case, I can make one single group of 4. One single group of 4, that's the biggest group that I can get, and it's a power of 2, so that's great. And if I want to work out what the expression of that is, I have to look at what they have in common. So I'll start here. Well, here I've got a not C and a C, so they don't have that in common. They've just got the D in common. And up here, there's a not A and an A, so they don't have that in common, but they do have the B in common. So the expression for this is just going to be BD. This is another example where I've got a K-map where I want to map for an expression which has 4 different terms, 4 different inputs in it. So be aware of the table headings, and be aware that the order of the knots is not, 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 not. Okay. So to map this, A, B, and C, not D. Now, here's the tricky part. How do we group these ones together? Because the rule is that I need to have groups of ones that are powers of 2. I also need to find the biggest group and the fewest number of groups, and I'm allowed to overlap. I'm not allowed to use diagonals, but I'm also allowed to wrap around the sides, either vertical or horizontal, but not diagonal. So it's possible to go, okay, we've got 2 here. We could wrap around and take this one, but that would give us 3, so that's no good. That doesn't fit. But if I had 2 here, then I would have 1 here, and I would have 1 here. So that would give me 3 separate groups. Now the rule is to find as few groups as possible. So what if I did this? Because I know that these 2 are connected by extrapolating the table vertically, so I can wrap this one around to this one. So essentially I wrap this one with this one. That gives me 1 group of 2. And then this one can wrap around horizontally. So I end up with these 2 together. So this gives me 1 group, and this gives me another group. So I've managed to group all of my ones in just 2 groups. 3 groups is not necessary. So sometimes it takes a little bit of thinking about. And if you do it like this, you have to then check, what do these 2 have in common? Well, they have the AB in common, we know that. Here, if I look at these 2, the C's are not in common, but the not D is common. So that's for the first group. And for the second group that you've got here, which is wrapped around here, this has got a not A and an A, so that's not in common, but they've both got the not B. So they've both got a not B. What else do they have? Well, if I look here, they've got the C and the not D. So my final expression is going to be these two terms added together. So it's this or this. So this thing here can be simplified to give you this expression here. This is my last example of a K-map where you've got 4 different terms, 4 different inputs. So again, get the table headings in the right order: not, 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 and not. So let's fill this in. So in looking for my groupings of 1, you might think, okay, well, I could have 4 individual groups of 1, but the rule is I need the largest group possible and I'm allowed to wrap around. Now, if I'm allowed to wrap around, that's interesting in this case because actually this one is connected to that one horizontally, but it's also connected to this one vertically. And that's the same. This one is connected to that one horizontally, and this one is also connected to this one vertically. So actually all of these belong to one single group because it's wrapped around into one group. So then you have to look at what do these things have in common. So this one has got not A, so the A's are not in common here, but the not B is. What else? The C's are not in common, but the not D is. And this is my final expression for something like this. So you can see where Karnaugh maps can save you a lot of time, because if you were to use algebra on something like this, you'd be there forever. If you map it into a K-map, then you come out with an answer pretty quickly.